AMR, to begin with, stands for automated meter reading. Basically, it is for utility usage, things like power and gas. It's actually an addition to your meter that allows it to upload data of your usage to either trucks passing by or tapping into the internet somewhere to get it to where people can get their meter readings without having to roll trucks to each house. So that's what AMR is, and we have seen a lot of cases where people have asked us, if we have basically the chips that are used in that system, and in effect we do. We have, but it's not an integrated module like a lot of our competitors have, and to combat that, we've come up with a few layouts that use discrete components with our devices, amplifiers, and switches. And it is, of course, bigger than a single module, but it's not that much. And the final layouts, if you do them, come out pretty good. Beyond that, there's a lot of other advantages to our approach. Honestly, I think cost is a big one. Being able to make very small modules with very small chips and drives you into processes that are very expensive. You can get away with that in the cellular industry because the volumes are so high, but lower volume things in the few millions here and there just don't seem like a good way to go. Our solution to multi-chip modules is really somewhat similar, but it's very simple. It's just a PCB with our parts put on it, matching components put on it, and biasing type things. Two metal layer, very inexpensive. So this is a mock-up of what we think we can do with a particular module that has two switches, LNA here and a power amp here. Just kind of works in toggle mode between the two. I've got these colored devices, which basically are either inductors or capacitors, in a few cases resistors. But what we have is our part with all the matching and biasing circuits in place takes up about 47 square millimeters. That is larger than a module, but it's very much cheaper and probably easier to manufacture. The customer in this case would take this PCB that it's on and mount that on to their own larger PCB. So kind of the same thing, but we've added another switch. This is designed to exactly duplicate a chip that's in the industry that's pretty popular. So we can compete with that on price. The nice thing about these processes, these simple surface mount soldering, is very affordable from a cost standpoint. Our 5509 amplifier, it's these switches are our GRF 601s, our LNA, and two more switches here in this case. All the switches are the same part number. The GRF 5509, that's been optimized for the design of the part has internally been optimized for the same frequency that this system runs at. It's in the 900 megahertz range. Here's one we've done slightly different. This would show you, first of all, this is the 2373 used in this design. 5526. So this is mainly for slightly different power levels or different noise figures, depending on what a customer would want. So that's why you see different part numbers used between the layouts. Basically, what we wanted to show here is this dark trace continuous is basically what the PCB would look like if you didn't put any RF connectors on it. You can maybe put small plug-in types, but if you wanted just a standard SMA connector, you widen the board out to these dash layers, and it grows the package size from the PCB size from 189 to 255 square millimeters. So you may not be able to visualize how RF connectors would connect to this board, but that's what it looks like. It also gives you a little bit of scale. If you know the size of an SMA connector, you really get a feel for how small the PCB is. Yeah, it is very adaptable, and what it really comes down to is if you change the functions or the switching or add chips or take them away, you just get a new PCB. It's very inexpensive to make. In effect, it can be quote customized to what our customer would want. We wouldn't sell that as it is, but for a given customer, on their own PCB, they can, however they allocate the space, what the shape is, and all that. A discrete design works on that in that situation. Issue is that in most cases, these modules that they make will go out EOL after 5-7 years, maybe 10. And for bigger companies that are making those chips, it's just they're not that worried about it. They'll sell them a new chip. So anything that needs to be replaced because of short lifetime is an issue. And one way to get around these custom modules is just having a simple, everything's not integrated. It's all discrete. So that's the advantage here. The size is, slightly bigger, but the costs work out to be very similar, if not the same. So that's the benefit, is that our parts will never go EOL as long as we can get them from the fabs. So the risk of using our module, I think, is a lot less than using one of the integrated modules from the competitors.
Thank you so much for watching. If you'd like more information, please email us at sales@guerrilla-rf.com. And don't forget to subscribe to our channel for more content from Guerrilla RF.